No, it's not. It's
All right, let's see what you guys got.
He said no.
Excellent, well done. Excellent, great attempts.
At least they were great attempts. That's what he said.
Exactly.
Yeah, I did my homework. We go. We need to go over the worksheet pretty quickly so that we have time to do the quiz review. So help me out. Did we do numbers 1 and 2 in class the other day? Because this was the assignment for a couple nights ago. We went over 1 and 2? Awesome, that'll save us some time. All right, number 3. Let's give ourselves a blank slate here. The first thing I do when I see a lot of triangles, do you guys see all the triangles here?
Yeah.
1, 2, 3, 4, 5. Oh man, there's a lot of triangles there. First thing I do, I go to the proof statement and I outline triangle A, D, B. And I outline triangle D, A, E, because those are the ones I'm trying to prove are congruent. I think I told you guys that yesterday to outline them. Now, if you really want to get crazy, you could even redraw them unoverlapped. You don't have to. Okay, this was A, this was B, this was D. This was D, this was E, this was A. Now let's go through the proof. AB congruent to DE. A, B congruent to DE, given. And mark it on the picture. AB congruent to DE. One pair of S's congruent. Also, DB congruent to AE. You could have put those on the same line or different lines, but that's another pair of S's congruent. So let's mark it on the picture. DB congruent to AE. Now this is where if you did it on the picture, the original, it gets kind of weird because it's like it's not an overlap side, but they're crossing. So it's a little bit weird when you go to look at it. So when I redraw these, it makes a little more sense. Okay. So I have 2 S's at this point, and if you remember our triangle congruence theorems, we have SSS, we have SAS, we have ASA, we have AS, and we have HL. Which of those has 2 S's in it? SSS and SAS, do you agree? So in my mind, I'm thinking, okay, maybe I'm working towards one of those 2. Let's keep going. We're out of givens. I use both givens. Now, what can you tell from the picture? Well, oh look, DA in this triangle is overlapping with AD in that triangle. Overlap, shared side, reflexive property. So is it DAAD or is it DADA? Reversed order or same order? Remember how to tell? Yeah, so DA in that triangle is AD in that triangle. You see it? That's the reflexive property. Oh, look, there's another pair of sides congruent. What do we have? SSS, triangle ADB. Go ahead.
Let's go.
S, S, S. How do we feel now? Good enough? Next one. GJ bisects FH. GJ bisects FH. And FH bisects GJ. This is not always going to happen where they bisect each other. So I'm going to walk you through it. I'm going to color code this for you so we can see what's the result from the green box and what's the result from the blue box. You ready? Are we bisecting angles or segments in this one? GJ is a segment, and it's bisecting FH, which is a segment. You have a segment bisecting a segment, but what's the knife? GJ or FH? What's the knife? Right, but in the green part. GJ bisects FH. GJ is the knife. FH is the string. Do you agree? Segment, picture, just a string held between your hands. Okay? FH is the string. Here's the string. F is stretching from F to H. Ready? Here come the scissors. GJ is the scissors. Just cut the string in half. What's the result of the green string getting cut in half? Grace, what do you think? If I cut that green string in half, what is the result? Excellent. Can you name them for me? Hold on one second. K. You said K what? H? Okay, other triangle. My bad. K, H, congruent to K, F. K, H, congruent to K, F. K, H, tick mark. K, F, tick mark. Reason. Definition of a bisector. Definition of a bisector. So what the green given, I put the result from the green given in green below it. Because you're not always going to have both parts. So we need to make sure we understand each part. Now it's time for the blue part. FH bisects GJ. FH segment bisects GJ segment. What's the knife now? FH. And what's it cutting in half? GJ. So here's GJ, minding its own business. Lo and behold, FH comes along and does what to it? Cuts it in half. How rude. Do you guys agree? That's the result. GK is congruent to JK. Seriously. Definition of a bisector. So we had a pair of S's. Another pair of S's. That's not very nice. S. We have two pairs of S's. Two pairs of S's. We're out of givens. So now we need to look to the picture and think about, are there any other proof hints, proof clues, proof hacks we see? Cool.
Vertical angle.
Ooh, I see those vertical angles too. Could you name them congruent for me? Name them correctly. Angle.
Angle GKF.
G, K, F. So he went along the blue segment to the center and then across the green segment. Go ahead.
And then HKK.
So you need to start at the blue segment on this one.
So JK.
Perfect. JKH. J, K, H. Vertical angles. So we have a pair of angles congruent now. The main key is that you named your three letters and that K was the center letter. Has to be. Okay? And if you get confused, go to the congruent statement, and when Cole said, as soon as he said G, K, F, that determined the order over here. J, K, H. J, K, H. All right, are we there yet? Do we have SSS? No. Do we have SAS? We do? We have a side? Included angle? Other side? I agree. Triangle. F, G, K. Congruent to triangle. H, J, K by S, A, S. Remember, side angle side is two sides in the angle where they meet. Two sides of the angle where they meet. Good so far. Next one. Again, outline the triangles that you're trying to prove are congruent. HAC is right here. HAC. And BGC. Oh, those ones, the ones that have an hourglass appearance. I should be thinking of vertical angles. Oh, look, C is a midpoint. What's the result when you have a midpoint? Two congruent sides. Oh, look, two segments are parallel. I should be thinking of alternate interior angles. Very good. We are well on our way. We have a good plan. C is the midpoint of a G. That's given. I'm going to put these in the same color because there is a result. There is a result, step 2, that goes right along with that. Okay, so you're walking from A to G. Walking from A to G. But you can't make it the whole way. You get tired. You stop at the midpoint, C. C is the midpoint of AG. Well, if C is the midpoint of AG, doesn't that make AC the first half of your walk? The same as GC, the second half of your walk? That's the definition. Good. Definition of midpoint. That gives us a pair of sides. Congruent. Other given, HA parallel to GB. HA, it's not parallel. HA parallel to GB. That's given. All right, now this is where our proofs can go different ways, and that's okay. Don't erase what you have. And you have to have that, but there are different routes you can take to get to the same ending. How many of you saw these alternate interior angles were congruent? How many of you saw these alternate interior angles congruent? How many of you used both? That's fine. That's fine. So this, do you see how this can be a little tricky because it's either one, any of those combinations are fine, as long as you get to SSS, SAS, ASA, AAS, or HL. I'm going to use these ones for now. And I'll talk you through it if you did it the other way, okay? So I'm going to say angle, if I call this angle AHC, congruent to angle GBC, reason, alternate interior angles. That's a pair of A's congruent. And earlier we had a pair of S's congruent. So here are the two options. If you use the other pair of alternate interior angles, then you would have angle, angle, side, congruent to angle, angle, side. You would stop after AAS. You didn't even have to use vertical angles in that one. If you used both sets of alternate interior, are you with me? If you used vertical angles, you would say angle, you could call it HCA or ACH, doesn't matter. Let's call it ACH, congruent to angle GCB, vertical angles. And now I have angle, angle, side as well. So triangle HAC, congruent to triangle BGC by angle, angle, side. This was our last pair of angles. So we had two A's and an S. How do you know if it's two A's and an S? How do you know it's not ASA? I had two angles and a side. How do I know it's not ASA? ASA, the included side, right? Okay, I have two angles. Do I have the included side congruent? No, it's the non-included side. Angle, angle, side. Yep. All right. I'm going to skip number 6. Okay, that was almost too easy. Here's what you have. No offense. No offense. Here, I'm just going to walk you through it. I'll talk you through it. I'm not going to write it all down. Do you see how you have two right angles? Yes? Yeah. Given. Now, we never said they're congruent. So you have to then say in a separate step, angle S is congruent to angle V. That's the right angle congruence there. And if you said the right angles, they have to be congruent. You have a pair of angles. Then you have a pair of given sides. You have another pair of given angles. So given, given, that's it. Triangles are congruent. Look, angle, 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 side. Angle, angle, side. You're not going to see that one that easy tomorrow in this. All right, we will work on the quiz review for part of class, and then we'll make sure we have some time to go over any questions you have. If we don't get through all of it, I'll post the video key on Canvas and you can watch it tonight. So I would definitely start with the questions. You can kind of work out of order. Start with the questions that you know you're going to need help on. Yeah, those are from my office. But there's one on Canvas if you want.
Oh, I can print it off.
Or I'll get them. All right, so when it comes to classifying triangle by angle measures, what are your choices for angle measure classification? Acute, angular, tricky, it's all right. Right? Obtuse. Good. So this one was equiangular. Classified by side lengths, equilateral. right, this one was obtuse. And our classification by side lengths are good. So this one was very good. All right, find the measure of angle n. Well, you have to use the exterior angle theorem. The exterior angle theorem says the exterior angle of a triangle is equal to the sum of the two remote interior angles. So this one happened to be y and y, so you had to add y plus y. No matter what these two are, though, you add them up and set them equal to the exterior angle. So in this case, it was 120 equals 2y, divide by 2, y equals 60. And since the angle is y, the angle is 60 degrees. So angle n was 60 degrees. Measure of angle n is 60 degrees. For this one, did you notice L, M, and N were the three angles in the triangle? What do the three angles in the triangle have to add up to?
180.
Good. Eight x, 2x, and 6x make 16x. 1 and -1 make 0. Divide by 16. X is 11.25. Is that right? Anybody help on that one?
I have question number 3.
Yeah, real quick. Was this one is 180 divided by 16, 11.25?
Yeah.
Thank you. Go ahead.
So number 3, did I just get lucky because I put 180 minus 120?
That gave you this angle right here. So yes, you got lucky. Because what kind of triangle is this? Equiangular, right?
Yeah.
And so all of them were 60. So you got lucky that that angle was the same as that one.
Correct.
So don't do that. All right, corresponding parts. Well, PR goes with XZ. XZ. Angle Y goes with angle Q. You with me?
Yeah.
So knowing the parts that go together helps us out with number 6. Number 6, find each value. So to find x, here's x. Here's an angle that has x in it. What's the corresponding angle to DAC? DAC. Well, BCA. BCA is 47. So I'm going to set 2x minus 3 equal to 47. Add 3. Divide by 2. X is 25. Not degrees. X is not an angle measure. All right, just 25. CD goes with AB. Those sides are congruent because the triangles are congruent. So I'm going to set 15 minus 4y equal to 3y plus 1. Add 4y. Subtract 1. Divide by 7. Y is 2. They didn't ask me for y, they asked me for CD. So I plug in y equals 2. 3 times 2 is 6, plus 1 is 7. So CD is 7. Good so far?
Yeah.
Next. QP bisects. QP bisects angle RPS. Here's RPS. That's given. If you bisect an angle, you get two congruent angles. Here they are. Angle RPQ is congruent to angle SPQ. That's the definition of a bisector. That's a pair of A's. So I use this given. The next given is angle RQP is congruent to angle SQP given. Well, RQP is right here. SQP is right here. Okay, so we have two pairs of angles. Oh, and the triangles are sharing a side. QP congruent to QP by the reflexive property. Reflexive property. So the triangles, triangle RQP congruent to triangle SQP by ASA. ASA. Know that one? Next, GF is parallel to JH. Ooh, I'm thinking of alternate interior angles. GF parallel to JH, given. So I'm going to say F is congruent to H, angle F. Why am I allowed to name it with one letter? F and H, I didn't have to use three letters. Good, because there's only one angle there. All right, alternate interior angles, that's one pair of angles. Okay, I use that given. K is the midpoint. K is the midpoint of FH. Oh, if K is the midpoint, K is the midpoint of FH, given. Doesn't that mean FK is congruent to HK? That's the definition of a midpoint, isn't it? So at this point, pair of angles, pair of sides. Gotta do some of my original work now. Another pair of angles, those are vertical angles. Angle GKF congruent to angle JKH. Those are vertical angles. There's another pair of angles, so I have two angles and a side. Is it ASA or is it AAS? Is the side between the angles or is the side not between the angles?
It's
Between.
between.
So A, S is between A. I gotta move quick. This is recorded though, so you guys can watch it as many times as you need. All right, when you plug in -6, you're gonna get side, angle, side, congruent to side, angle, side. When you plug in -6, you just have to show your work on that one. Christmas ornament is an equilateral triangle made of rope. The side lengths are 6.5. Well, if it's 6.5, 6.5, 6.5, 6.5 plus 6.5 is 13, plus 6.5 is 19.5 per triangle. Well, if we have 180, we're going to divide by 19.5. Help me out. Calculator out. I'm getting 9 triangles. 9 triangles with some left over. Last one, QP bisects an angle RQS, given. Here's RQS, it's this angle here. So if you cut that angle in half, you get these two congruent angles. Angle RQP congruent to angle SQP. The definition of a bisector. All right, and then the other given says QR is congruent to QS. Given. You guys see the shared side? QP congruent to QP, reflexive property. So triangle RQP, congruent to triangle SQP by which one's this? S, A, S. Make sure you guys, if you bisect an angle, you get two congruent angles, okay? Make sure you guys check this over. Watch it again if you need to. Ask questions. Have a great day.